please join me in welcoming Mr. Brooke Morrison.
Good morning. Fire safety and quality requirements. It sounds like the most boring topic you can choose for a conversation or for a presentation. And I'm sure if there was an award for this, I'd at least get a nomination for it. But why do we want to talk about quality requirements? Well, it's important to our industry. It's important to the nuclear industry. It's also important to fire safety. So, just before I start, I want to kind of put myself in perspective in this. I'm not a person with a formal quality background. My background is fire safety and engineering. That's where I come from. And but I've been one responsible for implementing it at our firm, and it's sort of drawn me into a lot of the requirements and everything. Now, I'm not intending in this presentation to take you through any details of what's in the standards or anything else on quality, but I would like to talk about how quality impacts what we do and what we should be conscious of in trying to implement and make sure we're doing things on a quality basis in the plant or in the facility that we're dealing with. So let's charge in here and see how we make out. So why do we want to do quality, or why does this apply to the fire or fire safety things that we do? I mean, if we're in engineering, we have all these standards that already tell us what we're supposed to do, supposedly. I mean, and there's all these building fire codes and standards on nuclear facility and fire protection. So they draw a lot of guidelines for us. For an emergency response, again, emergency responders are fairly highly motivated to quality because it's a safety issue. I mean, firefighting by its very activity is inherently dangerous. So nobody wants to have to go tell that their buddy on the brigade was hurt in the fire. So they're very motivated to quality and to making sure things happen safely. And again, they have any number of standards here which drive and try to implement the proper levels of safety and all for the activities, fire brigade, qualifications for officers, etc. So I'm going to touch just on quality here. There's one definition: a program for systematic monitoring and evaluation of aspects of a project or service to ensure the standard of quality is being met. And quality, like the fire industry, also is driven by a lot of standards, be they in the nuclear regulations, International Atomic Energy Agency, CSA, or ISO. They all have their quality standards. Now, these standards, like fire safety standards, go through revisions and updates from time to time. And the latest updates and the latest pushes on quality are geared towards two things. One is that they're process-based, that you know the processes that are required for what you're doing, and that you define them carefully and you know what that process is. The other thing is that, and you'll hear this term quite a bit with the quality groups and in the standards, is they're also risk-based. That you evaluate the risk associated with executing on a process. That you know what those risks are and you take actions to mitigate and make sure that you do not create unnecessary risks to the quality of the product or whatever you're doing. So those terms sort of jump out in the standard. So the fire safety activities that we get involved in, I've broken into these four categories. Design, of course, we're going to design a station, and there's various fire protection standards we put into place or processes that are taking place there. We have these assessments that we perform, and they also have to follow some quality process. We have a fire protection program, and then, of course, emergency response. So, what are the key components? And I've just selected ones here out of the standard, which I think we can all identify with as components in implementing quality at a plant or at a facility that we might be working at. So, first off is you have to have a defined organization. And in that organization, the roles and responsibilities within that organization must be known, and the people working in it should know their responsibilities within that. It all gets kind of confusing if we're not. We must manage the information that we're using when we're doing fire safety or involved in different parts of fire safety. We have to have our inputs and make sure that we know that they're accurate, particularly if we're on the engineering, but even on the emergency response when we're looking at responding to hazards and doing pre-plan. We have accurate inputs. And then we have some process we're going to do in, but we also have to look at managing those outputs. What are we really producing as a service or as a product to the end of an engineering activity, and do we understand what's required in that output? Talked about it being process-based quality standards now, so what they're suggesting is that all work processes are understood and managed, and the common way that they do, or the most popular I guess now that you see, is what they call these swim lane diagrams, where any process that I have to repeat, I define for each of these swim lanes, there is a person or position identified, and I show the process and who's responsible for each part of that process, so that I know it's going to be done accurately and consistently in the same way, so I get a quality output. We have to apply criteria. In our industry, that's pretty clear. We have these standards that tell us what is expected of us, what we have to meet as far as requirements for maintaining safety or for emergency response. So these standards give us these requirements. Resources. Resource management is important, that we know what resources are needed to do any job or any process that we have, be it the fire hose or the equipment we're using to apply water in emergency response, personal protective equipment, whether it's software, which is the upper right that you have to do an engineering task, and I have to have software to run that. And of course there's the people part of it, which is the big part of it. We have the human resources that are required to execute and make those processes happen. It's not enough just to say we're going to do something and do it consistently. We have to also document that and show that we have what the results of that are. So it's going to be documented. Somebody's going to be able to go back and take a look at that process and say, yes, I see a clear documentation that you followed those steps you said were necessary to do it in a quality fashion. So that's another key component. And then the final one we have here is, of course, that we have to do some assessments of the processes we do just to make sure that we are doing what we said we were going to do. So those are sort of the components that apply to almost whatever you're doing in fire safety. These all sort of apply. So what I'd like to do here is spend the rest of this presentation is talking about these components, talking about different things we do in fire safety at a facility, and just show, I'm going to share some examples both from my own firm and from things that we see when we're doing reviews to see whether qualities, are we meeting what our requirements are in quality. And the other, I guess, principle that's usually involved in quality or you hear about is this constant improvement. I've got to constantly be trying to improve what I'm doing. That's why we do a lot of the things in these in our programs. Fire safety, we tend to think if we're doing engineering parts of it, or if we're doing fire response, gee, I've got a responder, therefore he can do whatever, he can do all these tasks. Well, this is not true. I mean, when we look at doing these engineering tasks, this is just a matrix that we set up in our firm that lists some of the services and things we do in the nuclear industry, and said, well, who's the one that has the qualifications to do this, and who has the ability to do that in a quality fashion? And as you can see here, this is a laser work. As you can see, there are a number of things, and nobody has all those experiences. Nobody has all those items covered. You need a team of people so that you can cover off on those various items. Quality, if you read a lot of quality documentation, the other terms you hear when you look at human resources is the big focus right now is on this item they'll call, when you're looking at human resources and you're looking at somebody doing a specific task, whether it's emergency response or it's doing some engineering or fire program item, that they have the knowledge to conduct that task. they not only have to have the knowledge to conduct that task, they must also have the competency to conduct it. And what they're requesting there and they're looking for is that you have some demonstration that they know how to apply the textbook knowledge or the classroom knowledge that they may have accumulated. It's not enough just to have the knowledge, you've got to know how to apply it. That's where they're bringing in the competency issue. And so it's good if you can and in the training requirements you're looking at, then you should be able to document that both have been looked at. Now different fire areas of knowledge are not enough in a lot of the things we do, particularly on the engineering side. There's other members of the team here from nuclear safety, radiation exposure, probabilistics, as Elizabeth was talking about. There's a whole different skill set again. And we might be looking at seismic people to give us information on what happens in seismic events. So it's all about putting together a team with that background and the resources to handle the problem. There are 3 assessments, fire safety assessments, that take place at a power plant. There's 2 at least that take place at other nuclear facilities. And I just want to sort of walk through. Here's the process. You hear me talking about some of the key components. So let's just talk about those as far as one aspect when we do these fire assessments is to look at, some fire scenarios. So I'm in a process within a process here, which is another thing we see in defining ourselves and how we're doing things. So let's just look at this required inputs. You remember we talked about that, define process, some criteria and all. So let's look at this. So where's your inputs coming from? So somebody has to go and get the information that's required to conduct your assessment and validate that data, make sure it's available and that everybody is using the same information. And I think that was alluded to with some of the previous speakers. We have this challenge here of making sure everybody's playing from the same score sheet here or whatever. And then the data is common set that everybody is using, and every once in a while we find people sort of wander off and get information from another source, and you're saying, where did that come from, But if we're going to do this consistently, we have to have a control on those inputs. So I talked about a process within a process. This fire scenario development is really this process within this assessment process, where I'm doing some screening assessment to identify what rooms I need to do fire modeling in. And then I do this looking at my fire models or a fire scenario within a room. And it's important, though, to also realize where the next piece of information goes. In this case, I could be looking at, I determine the fire conditions in a room. Then I have to look at how that impacts on nuclear safety or nuclear materials that might be present. And then, of course, what's the safety consequences related to that? So there's the process. I know where it stands. That's important to understand those items. We look at a fire scenario. We're looking at determining criteria. So some of the criteria may be the level at which safety systems or nuclear items are damaged in a fire event. So these sort of criteria we apply. We do some fire model, and we figure out that we do have some impacts. I'm going to skip over the resource thing. This is a documentation of outputs, and this is a summary office system we're using, but defines the top part with there's a blue band, and you'll see some gray text there. That's just defining all the details of the fire scenario, and it's not very visible, but in that under the second blue band there, you'll see some little red squares. So those are looking at the fire safe shutdown system at a power plant, and it shows a red square when there's a failure that would cause an inability to reach one of the fire safe shutdown conditions. So that's determining the consequences and the output of that fire modeling process. And there's our documentation to show what we've done and what's there. Okay, I want to spend the rest of the time that talked a little bit about process, and I think everybody's pretty. I mean, our whole industry is driven towards these, and we have these. We know pretty much the process of what we're doing in these criteria. We have these standards, But let's look at some details and say, you know, are we really capturing everything? So I've got some examples here to illustrate a couple of different points. And this is at a review stage on a design. And this was actually, I kind of made up this slide, but this comes out of an example, and I've lost the slide. It was on a slide from quite a while ago. And this is back in the U.S. when they first started after Browns Ferry and all separating redundant systems and everything. And they found one electrical room where they had redundant switchgear right next to each other. So that's what I'm trying to represent here. So the question was, though, is it needed a 3-hour separation? So the question was, the opening between it wasn't very big, and they could either block it up with a block wall or put in a rolling fire door. So the question is are those equal? So now I need a resource here that knows the difference between these, and are they equal? Well, no, they're not. I mean, a barrier has a completely different acceptance criteria for a fire barrier test than a door does. A door is allowed to have passage of heat and flame where the wall is not allowed to do that. The door assumes that there's a passageway on either side of it. That's why it allows a little different criteria. So for the standard, or to meet the intent of what the nuclear regulations were trying to achieve, we need to put up a wall. That's just an example of some of the things that come forward and the need for that resource that has that knowledge. Let's take another little one. I've run across this on more than one occasion. It's been a couple of occasions that we've seen it in our office. So this is all facilities do this management and change, CSA and 293 and 393 have it, and FPA 801 if you're using NFPA system. So I have to do an independent review, a change, and check that it meets the nuclear safety and fire safety requirements. So there's this one on fire alarm, and the story here is this, they were changing out the detection in a cable tunnel. And they came and said, well, here, we're replacing it with this detection system. Everything met the standard. And I was looking at this and I said, well, this doesn't make sense. They're replacing like for like, it appeared to be. So I went and talked to the designer. I said, why are you changing out the existing detection system? He said, we get too many false alarms. I said, why do you get false alarms? Have you done an investigation? Yes, we did. Why are you changing? Well, it's too humid down there, and we keep getting this moisture, and we keep getting false alarms. And I looked at the detector that they're replacing it with the detector that was existing, and they both had the same maximum relative humidity requirement on the thing. So as a design issue, this environment met the standards, except it wasn't good for that environment. So there's a quality check, and I mean the system works. I mean we could say that that's good that it's in the standard. We have a review process, and we're picking up those things. But hopefully you would get it the first time. Take a look at another one. This one is kind of near and dear to my heart, but is one that I think is a bit problematic in our industry, is water supply. So here's another example where I have a fire pump that's being put in a building because we couldn't achieve minimum hose pressures at the most remote hose station. So they had to put in a new fire pump, and they could achieve at the most remote point what the minimum pressure requirement is. Thing is, back at the source at the fire pump, our discharge pressures were quite high. So I said, this pump feeds more than one system, so what else is on the system? Well, lo and behold, there's other sprinkler systems being fed off it. They're existing, and they're only set up for a maximum working pressure of 150 psi. So somebody's got to do something here to figure, because they're tested to 200. They're not potentially going to survive the assault that they're going to get from this pump kicking on and operating. So again, just checks on this. We've had other water supply situations. And water supply is very tricky because you're trying to solve a problem in one place, and you have to make sure you don't create another problem at another location. And finally, make sure that we have documentation of what that demand is for all the systems in the plant, and that our supply meets all of those requirements. Is a time-consuming task a bit, but it's necessary to make sure that we're gonna do them properly. I think some of the previous speakers talked a little bit about this documentation and communication. That's always a challenge in a group. Even when you have a common background, as we do in fire, there's still all these challenges to communication and documentation of what we do. So I'm sharing a few things that I've seen in reports and all. So here's one on a fire, coming out of a fire hazard assessment, said, NFPA 30 requirement, site efforts, as well as the WAC work type of oil temporarily stored. Now, I don't know if anybody here knows what this WAC, WRT type of oil is, but I sure didn't. And every once in a while we get working with a problem where we throw in our own terminology and we know what we mean, but not everybody else reading it will necessarily know that. Here's one of a fire extinguisher procedure. I was doing an audit once at a plant, and I'm reading through all these very boring requirements for extinguishers and testing them and checking them and everything else, and I come across this hydrostatic testing. Should we specify frequency? Is there a standard for this? So somebody had questioned that they didn't have anything for it, and written it on this procedure. It had been modified, and they had typed in the question. It had been reviewed by one person. It was approved by another person, and there was like 4 signatures on this procedure, all saying yes, we're okay with this procedure. And somebody had raised one absence in it, but it didn't get addressed. And all they did was type in the question. Here's another one from a fire hazard assessment at a nuclear plant, and this is one, again, coal dust should be removed from the cable trays. Well, it's pretty hard to get coal dust in a nuclear power plant. But it does highlight one of the things that I know in doing reviews that we see quite a bit is the copy command on the computer is so efficient. I can copy stuff and paste it, and then I quickly edit it. And this is just an example of, and if you do it quickly, you read through it quickly, it kind of makes sense to you, but when you look at it as a third party, you say, hold it here, is this really what you want to say? That doesn't always come across. So I wanted to have one also, one example of communication for emergency response, and this one I know about, it was shared with me with another emergency responder I thought I'd do. So this is the first fire officer arriving on a call, and here's his communication back to the dispatch when he arrives. Chokes mowing. So he said it quite fast, but I think he communicated the point. But it's awful easy in the excitement and everything, and particularly in fire service, they do a lot of training on this, is how to take a couple of deep breaths, slow yourself down, make sure you're doing an effective communication of what you want to say. We also do a thing internally in our organization where we talk about the difference between temporary and permanent communications. And when you're writing engineering reports, it's a permanent communication. It goes on file, the plan goes to the regulator, goes to everybody. Make sure you get it right. Fireground are a little shorter lifespan. Let's just talk a little bit about emergency response. This is not my area of expertise, although I was a firefighter for a short time, and I enjoyed the experience a lot. And I am aware of what some of the standards are requiring. And it's all about training. I mean, one thing with emergency response is we do more training and activities to prepare for an event than we ever see events. This is a good thing. I'm not complaining about it, but it is something that we have to keep drilling at, because things that happen frequently are hard to prepare for. And so they do a lot of training. They do emergency pre-plans. They're doing drills. They're sharing operating experience with other groups. The more realistic we can make this training to what their person's going to see, the better it is. And so these most facilities, and you've heard a lot about the training grounds that exist around the globe, and there are a lot of good facilities, and no one can cover everything. The standards require that you do an audited drill every other year, within the facility. So we can check all the communications and everything else that's necessary, but that doesn't really simulate very well these conditions that the fire and emergency responders are facing. Communication is of course the biggest challenge to not only within the crews and at the command post that the emergency responders are using, and it was already referred to I think this morning, this communication also with the control room is something that we had down as well, has been noted. I mean, this operations and how they're dealing with the operation of the plant with this emergency and whether it's threatened is an important communication. The other issue that we find is this hard to do and real hard to cover, but this we've had considerable discussions internal to our organization about a demonstration of sustained intervention. I mean, there's only so much time on an air bottle, and the firefighter, the first crews go in, but can we sustain our emergency response effort and keep rotating people in and out of that to make sure that we're not putting anybody at risk either through fatigue or running out of air or whatever. These are all issues. I found it very interesting, Paul Sarah yesterday morning talking about this simulation of radioactive exposure and acceptance of conditions that the responders are going into. So that's very good feedback. We can use that, try to improve what we're doing as a quality item. Here's another kind of a share with you. I'll share with you. There's of course site condition inspections are required. They're required by the standards, and so we have an independent site condition inspection. Now, the fire program is working well. You would think that we wouldn't be finding too much, but the nature of the world we live in, stuff is changing constantly. There's also things that we see that we all of a sudden realize, well, that's the way it always is. So, you know, sometimes it's accepted just because that's the way we're used to seeing it. And that's why independence sometimes is helpful to come in and get some fresh eyes to it. So here's a few pictures of some stuff that we've seen or some conditions that we've seen in the course of our activities. So this is the one I like. I had a professor at university who used to talk about the little wooden wedge that people would put under fire doors, you know, and he used to call that a 2-hour rated wooden wedge or door opener, you know. Now this has got to be a 4-hour. I mean, this is a rock. I mean, it's not going to be. So we have a 4-hour rated door hole. This is at a this is at a mine, actually, a uranium mining facility. So the atmosphere in some of these areas is not all that clean. And again, things like this, the heads that are fire protection is being plugged up like that, they've got to be replaced. So every once in a while you see things, but if you're looking at it every day, it gradually builds up and you just don't notice it. Ah, dear, the fire department will find the hose cabinet now. You know, again, stuff happens. Where do I put things? You know, this is always a challenge in most facilities. The space is at a limit, so things get shoved in corners and everything, and we end up hiding some of the fire protection equipment. So that sort of event occurs as well. Now, this on the surface looks pretty normal. I mean, guess what? I mean, we've been pretty good with computers now, so we don't print out stuff nearly as much as we used to. So the IT department had all these printers that were being decommissioned, and they were looking for a place to store it and found some square footage to store it in. And it happens that this is at the back of one of the control equipment rooms at a power plant. Now again, our transient controls, this is of course a high-risk area. We don't want to be having hazards in there, so it's just one of these things. Hey, why here? Eh? Well, let's get it out of there and not have that in a high-hazard area or where it could have impacts to nuclear safety. So it's funny the stuff you see, but that's, as I say, it's a complicated thing with fire safety and trying to maintain fire safety. There's a lot of people doing things, they don't understand the world we live in, and we have to kind of help them understand it. So, in conclusion, what I just want to touch on here is this. Right now, I mean, we're sort of in a funny age. I mean, time is everybody's got used to getting things in yesterday. They want this instant feedback from the computer, or they want to be able to push something and get it. There's a pressure on the money that's available to do things, and these two pressures on managing fire safety are a bit of a challenge. You know, and this is, how do we deal with this? Well, my point here is whether we're doing a uranium mine, uranium processing, or power plant, these key components of having a quality and having a program where you have worked out what your organization is, what your information requirements are in your work processes, and having the resources to do it is key to being able to meet those time and dollar crunches that everybody's under to get it done quickly and accurately, and make sure that we're meeting the performance requirements that are demanded of our industry, which are high. We must be able to demonstrate that we're keeping the plant safe. So quality programs help us, or those quality principles help us to kind of work ourselves so that we are organizing ourselves to do these things quickly, and yet making sure that we don't miss things that are important to achieving overall safety. And I think that's just about as much as I have to say about that.